Hello friends, welcome to the chapter 4 of Methods and Techniques for Business Data Analysis. Today we shall look after the determinants of part 2. So in part 1 we had looked for how to find out the determinant of A or determinant of B or C, and in the same way we had found out how to find out this Cramer's rule. So today we shall have a look on what is minors, cofactors and adjoint of a matrix. So here while doing the sums itself, I will tell you how to find out this minor and what do you mean by this cofactor and what do you mean by this adjoint of a matrix. So it will be easy to find out the whole thing. So here example, you have a sum A is equal to 3, 4, 5 and 8. So here if you have everything in plus, so everything in the symbol plus, so then it is easy to find out the value. So how you are supposed to find the minor of the elements? So if you want to select the minor of 3, so always there is a rule in a determinant. So if you select this, the row and the consequent column has to be cancelled. So remaining will be 8. So the minor of 3 is 8. So in the same way, the minor of 4, the consequent row and the consequent column has to be cancelled and the remaining will be 5. So the minor of 4 is 5. In the same way, for the minor of 5 is 4 and the minor of 8 is 3. So here you can think this is 1 1 1 2. So this 1 1 represents first row, first column. So the number 3, so this is in first row and the first column. So here minor of 4, here they have written 1 2. So 1 2 is nothing but first row, second column. So that is how you have to write. So this is second row, first column, second row, second column. So this is been called as M21 and M22. So after finding the minor of the factor, so then you have to find out the cofactor of the elements. So cofactor, this is very important. So if you want to find out the cofactor, once again C11, C12, C21 and C22. So if you want to find out the cofactor of 3, already you know the element of the minor of 3, so that is 8. So always there is a symbol which will represents the plus and minus. So every time be careful, every time how you are supposed to take is plus, minus, minus, plus. So this is how it will come. So that is why what you are supposed to do is plus, minus, minus and plus. So plus into 8 will become plus 8, minus into 5 will become minus 5, minus into 4 will become minus 4, plus 3, plus into 3 will become plus 3 itself. So how you will write is 8, minus 5, minus 4 and 3. What is the adjoint of A, they are asking. So to find out the adjoint, so it's nothing but the transpose of the cofactor matrix is called as an adjoint of a matrix. So this is what you are supposed to find out. To find out a cofactor, you require a minor of a matrix. So to find out the adjoint, you require the cofactor of the matrix. So the transpose, so that is interchanging of the rows into columns. So 8, minus 5, minus 4 and 3 you have. So for this, if you want to find out the adjoint, so it's very simple, that is change the rows into columns and the columns into rows. So this is first row 8 and minus 5. So this has to be written in column format, that is 8 and minus 5. So once again here you have second row, that is minus 4 and 3. So this has to be written as the second column minus 4 and 3. So the interchanging of rows and columns is called as an adjoint of matrix or adjoint of determinant, what you are finding out. Next problem. Here you have to find out the cofactors of the matrix of A for the determinant 3. So here you have a value of determinant 3. So when you have these type of problems for the value of determinant 3 into 3, be careful. So first you have to find out the cofactor. So for 5, this is first row, first column, first row, second column, first row, third column. So this you will write as 1 1. So this you will write as 1 2 and this you will write as 1 3. So in the same way 2 1, 2 2, 2 3. So what is the 2 1, 2 2, 3? 2 3 means cofactor 2 1, cofactor 2 2 and cofactor 2 3. So for 5, how you have to find out? So for everything there is a rule. So how you are supposed to do is, for 5, what is the minor factors you have to identify. So for this 5, this consequent row and this consequent column will get cancelled, and you will be remaining with 1, 2, 2 and 1. So this is the rule for everything. So always you should write -1. So this -1 is according to the format. So -1 you have to write in brackets. Then how this 1 plus 1 come is, here you have 1 and 1. So you will write as 1 plus 1, that is first row plus first column. So then you will write. So after writing this, 1 into 1 will become 1. Then 2 into 2 will become 4. So according to the format, minus should come here. So 1 ones are 1, minus 2 into 2 is 4. So then how did plus come here? So this is very important. How you are supposed to find out is, -1 to the power square, that is -1 into 1 will become +1. So that is why plus symbol will come here. So plus into -3 will become -3. So this is how you will identify. And we shall look for the second one. So if you want to find out the C12 value, that is 2. So here you have 2. So cancel this column and cancel this row, that is 5, 2, 3. So you will be remaining with 3, 1 and 2, 1. So you will write as 3, 1 and 2, 1. So before writing, what you will write here, -1. So here you have C12. So that is why you will write as 1 plus 2. So 1 plus 2 is cube. So -1 to the whole cube will become -1 itself. So that is minus will be the symbol what you will be writing here. So 3 into 1 will become 3, minus 2 into 1 will become 2. So 3 minus 2 is 1. 1 into -1 will become -1. So this is the same rule for every number. So for each and every number you have to find out according to this way itself. So after finding according to this way, you will find out the cofactor of A. So that is -3, -1, 5. According to the order you have taken. So according to the order you will write according to that. 4, 2 and -8, 1, -1 and -1. So this is the cofactor of matrix A. And even in this problem it's according to the same. So do practice even that problem itself. Find the adjoint of A if you have a value -5, -2, 7 and 3. So here you should be careful. Why? Because in the first example we look for all the digits which has plus symbol. So here you have some negative and here you have some positive. So when you have this method, so you should be quite careful, and hence show that A into adjacent A is equal to determinant A into I. I is nothing but the identity matrix what you have to look for. So here you have to find out what is A, and here you have to find out the determinant A itself. So first you have to you find out what is the determinant of A. So in our first part of determinants we have looked for how to find out the determinants. So very simple. 5 into 3, that is -5 into 3 minus 7 into -2. So -5 into 3 minus 2 into 7. So -5 into 3 will become -15. -7 into -2 into 7 will become -14. Minus into minus will become +14. So -15 plus 14 will become -1. So this is the value of determinant A. So now you have to find out the cofactors value. So to find out the cofactors, so now in example 3 we found out how to find out the cofactors value. So according to that you have to find out the cofactors. Here they have done directly. So what you are supposed to do is, here they have done directly. You should find out the cofactors of -5 and 7, -2 and 3. So here, as the numbers have both negative and positive, so this is the rule what you have to go with. -1 to the power 1 plus 1. Why sir it is 1 plus 1? So here you have 1, 1. So here you will write 1 plus 1. So then once again here, minus 1, 1 plus 2, minus 1, 2 plus 1, and minus 1, 2 plus 2. So this is how you will first make sure you will write that. So here you have written as minus 1 into 1 plus 1. So the cofactor of minus 5. So here 3 will be there. So the opposite number. Why? Because if you are taking this number, the consistent row and the consistent column will get cancelled. Only 3 will be remaining. So here 3 is there. So here minus 1 into square. So minus 1 into minus 1 will become plus. So that is why plus into 3 will become 3 itself. That is, it will be positive here. So for minus 1, that is, if you are taking the cofactor as 7 to find out the factor of 7, so then this row and this column will get cancelled. You are remaining only with minus 2. It's very simple. That is the opposite number what you will take. So minus 2 is the number what you have taken. But here minus 1 to the power 1 plus 2, that is minus 1 cube. So minus 1 cube is nothing but minus itself. If you multiply minus 1 3 times, you will get minus symbol. Minus into minus 2 will become plus 2. So for the cofactor of minus 2, here 7 is the number. So minus 1, 2 plus 1, that is 3 itself. So minus into 7 will become minus 7. So in detail they have not given. So you have to understand how you are supposed to do. So here once again to the factor of 3. So the cofactor will be minus 5. Why? Because the consistent row and column will get cancelled. So you will be remaining with minus 5. So here minus 1 according to the rule. 2 plus 2. What it will become? So 2 plus 2 will become 4. So minus 1 if you multiply 4 times, it will get plus. So plus into minus will become minus. So here symbols are very important more than what you are writing. So once you get to know the symbols, it's very easy. Or else what we can do is directly plus, minus, minus, plus. So this is how also you can write. Always the symbols will go like plus, minus, minus, plus. So why we are writing this minus 1 is for your better understanding how this plus and minus comes. Or else according to the rule, this will always be plus, then it will become minus. So once again this will be plus and this will become minus. So directly also you can understand this. Once you find out this, you will get 3, 2, minus 7 and minus 5. So next, if you want to find out the adjacent of A, that is this value, it's very simple, the interchange of rows and columns. So 3 and 2 you have in first row, so that you will write in column as 3 and 2. That is, first row will be interchanged as first column, second row will be interchanged as second column. So next what they have asked, that they have asked for A into adjacent A. You have a value of A and you have a value of adjacent value, that is adjoint value. So now multiply according to the matrix, first row into first column, first row into first column. So minus 5 into 3 will become minus 15, plus 7 into 2 will become 14. So the second, after doing this, first row second column, that is minus 5 into minus 7, 35 plus 35. So 7 into 5 will become minus 35. So once again, second row first column, minus 2 into 3 will become minus 6. 3 into 2 will become plus 6. Once again, second row second column, minus 2 into minus 7 plus 14. 3 into minus 5 will become minus 15. So 14 minus 15. So now calculate. Here you will get minus 1, 0, 0 and minus 1. So this is the value of A into adjacent A. So now you have to prove that adjacent A value, that is the determinant A value into the I value. I is nothing but the identity matrix. The diagonal elements will always be 1 here. So minus 1 is the value of the determinant into identity matrix will always, the diagonal value will be 1, 1, 0, 0 and 1. Now multiply with minus, this will become minus 1, this will become minus 1. Anything multiplied by 0 is 0 itself. So you will get a value as minus 1, 0, 0 and minus 1. So hence you have proved that A into adjoint A or an adjacent A and determinant A into identity matrix will get the same answer. So finally you write as hence proved. So this is how you have to find out the overall adjoint portion. next you have something called inverse. So whenever you have inverse, you can go with two methods. Always go with an method 1 itself, so which will be an easiest one. So find the inverse of 2 minus 3 minus 4 and 5. So according to method 1, so first whatever is there you will write that. So next what you are supposed to do is you should find out the determinant value every time. So the determinant of A will be 2 into 5 will become 10, minus 4 into minus 3 will become minus plus 12. So already minus will be there, so minus plus into minus will become minus 12. So 10 minus 12 is minus 2. So now you have to find out the cofactors, that is 1 1 1 2 2 1 and 2 2. So for every number you will find out the cofactors. So first you will find out the cofactor of 2, and next you will find out the cofactor of minus 4, and next you will find out the cofactor of minus 3, and next it will be 5. So as already told, either you can write according to minus 1 1 plus 1 or else. So I have told you the method, that is plus minus minus plus. So this will be the symbols which will be there. So for cofactors 1, so for an factor number 2, the cofactor what you should find is 5. So that is this minor, this row, this column will get cancelled for 2. So the remaining is 5. So you will write as 5. As I have already told the symbol, you can write as directly plus 5. So for minus 4, minus 3 is the symbol. So minus into minus will become plus 3. So for minus 3, minus 4 is the minor, that is the factor. So minus 4 is the value into minus. So minus into minus will become plus. So you have written as plus 4. And for 5 you have a value 2. So for 2, what is the symbol? That is plus is the symbol. Why? Because plus minus minus plus. Plus 2 will become plus 2 itself in the final thing. So the overall cofactor is 5, 3, 4 and 2. So now you have to do the transpose. Why you will do the transposes? For adjacent A, you should interchange 5 and 4, 3 and 2. So till then the method is same. To find out inverse, so inverse is nothing but adjoint A divided by determinant A. So the adjoint A value is 5 4 3 2, determinant value is minus 2, what you have found out at the first. So this minus 2 has to be divided. So what you will do as adjoint A to the power minus 1 is equal to, so there it is minus 2, so you will write as minus 1 by 2 into 5 4 3 2, or you can also write as 5 4 3 2 the whole divided by minus 2. So instead of writing like that, in a very simple way, so in numerator if there is nothing, it is called as 1. So minus 1 by 2 into 5 4 3 and 2. So this is how you will find out the inverse value of A. We shall look for one more problem in this inverse matrix. So 2 3 minus 1 and minus 2 is the value of matrix of A. So first, according to the method what I told, you should find out the determinant value. So 2 into 2 will become minus 4, minus 1 into 3 will become minus 3. So as already you will be having minus, minus into minus will become plus. So minus 4 plus 3 will become minus 1. So this is the determinant value of A. Next you have to find out the cofactors. To find out the cofactors C11, that is the first value, first row first value, first row first column, first row second column. This is second row first column and second row second column. So here directly they have done. As I told before, plus minus minus plus will be the symbols. So for first row first column, what is the element which will be remaining? Minus 2, that is the opposite value. For minus 1, for this value, what is the number? 3 will be remaining. For 3, which is the number? Minus 1 is the value. For minus 2, which is the value remaining? 2. So that is how you will take the values opposite, which is diagonally, or else according to the rules. If you are selecting a number 2, that is first row first column, the adjacent row and adjacent column will get cancelled. So the remaining number is minus 2. So that is how you will find out the minor. So in example 1, you can remember that. So plus into minus will become minus 2. So already you know what is the symbol. Minus into minus will become plus. So here be careful, here actually it's not minus 3, it's plus 3. So it's a printing mistake what is been here, so be careful. So this minus is correct. So here actually it should be plus 3 because in question they have given us 3 itself, but according to some printing mistakes here they have given us minus 3, so it is plus 3. Minus into plus 3 will become minus 3, and here minus into minus 1 become plus 1, and plus into 2 will become 2 itself, that is the positive digit. So next find out the cofactors. You have found there minus 2, minus 3, 1 and 2. So for this adjacent A, so that is you have to find make the interchanging of rows into columns. So minus 2, 1, minus 3 and 2. Next inverse, you have a formula adjoint A divided by determinant. So the adjoint value is minus 2, 1, 3 and 2, and you have a determinant as minus 1. So instead of writing divided by minus 1, you can write as 1 divided by minus 1. So next, as you have minus here, is equal to 1 divided by 1 will become 1 only. So here you have minus value, so minus 1. So anything multiply that value will become the same. So that is why they have written minus 2, 1, minus 3 and 2. So here you will be having minus only. Why? Because 1 divided by 1, minus 1 will become minus. So now this minus into this minus will become plus 2. So minus into plus 1 will become minus 1. Minus into minus 3 will become plus 3. Minus into 2 will become minus 2. So this is how we will find out the adjoint value, that is first at first factor. So then you will go with the inverse of matrix A. So for this finding out of inverse of matrix, so you have a formula adjoint A divided by determinant. So finally you will get answer as 2, minus 1, 3 and minus 2. So be careful whenever you are finding out the minor of a matrix. Whenever you are finding out the minor of a matrix, so it's very simple. Whatever number you are selecting, whatever minor number you are factor selecting, cancel the adjacent row and column. So the opposite number or the diagonal number what will be there, so that will be your minor for the number for what you are selecting. So once minor is been selected, find out the cofactors. So for cofactors of value of determinant 2, plus, minus, minus, plus. So if you want to go through the same way in 3-digit factors also, it will be in the same way, plus, minus, minus, plus, plus, minus, minus, plus. So this is how you will make sure. So always plus, minus, plus, minus. So if one value is plus, the second value will become minus, once again third value will become plus, fourth value will become minus. So go with the formula what we have given, that is minus 1 to the power 1 plus 1, that is first row first column. So once you are done with that, then make sure you will find out the adjoint value. So to find out the adjoint value, you should change, that is the interchange of rows and columns has to be done in cofactors. So if it is done, you will find out the adjoint value. So finally, to find out the inverse of a matrix, so inverse of a matrix has a formula, that is adjoint A divided by determinant of A. So if you are done with this, so this is the second part of your determinants what you have to understand. Good luck, happy learning, thank you.